So, what if I told you that one of the biggest leaps in technology since CGI wasn't unveiled at some big tech conference, but was actually hidden, decoded in the lyrics of a song? That's what we're doing today. We're going to break down how a few cryptic lines of music might just unlock the future of how we see and interact with reality itself. It all starts with this one line: 40 splats on the pavement. Tell me where the light went. I mean, it sounds like some kind of abstract poetry, right? Kind of cryptic. But what if it's not? What if this is a literal, technical description of a brand new medium? That's the mystery we're unpacking. And that really brings us to the big question, doesn't it? Are we listening to science fiction here, or is this song describing real tech that's actually here, today? As we're about to find out, that line between art and engineering is getting very, very blurry. All right, let's start with the big picture. The song hints at this world where what we're seeing isn't quite what it seems, a reality that can be, well, manufactured. And this lyric just nails it. We have actually reached a point where we can capture and recreate moments from the real world so perfectly that they're basically indistinguishable from the original. We're not talking about simulating reality anymore. We're talking about replaying it. Okay, so what in the world is a 40 splat? To really get that, we have to start with a foundational technology that makes it all possible. It's time to decode the splat. And check it out, the song gives us another breadcrumb: point cloud precision. This is ground zero. Every single kind of 3D capture, whether you're talking about a Hollywood blockbuster or preserving ancient artifacts, it all begins with a point cloud. Just a massive, massive collection of individual points all mapped out in 3D space. Now here's where things get really wild. How do we get from that cloud of dots to something that looks real? Well, instead of playing connect the dots to make a solid shape like in a video game, Gaussian splatting takes each point and turns it into a soft, fuzzy, semi-transparent blob, a Gaussian. You literally splatter millions of these things together until they merge into a perfect, complete picture. And this shows you exactly why it's such a huge deal. Old school photogrammetry builds a digital sculpture, and then it tries to simulate how light would bounce off it. But Gaussian splatting? Totally different. It creates something called a radiance field. It doesn't guess or simulate the light, it directly captures the light from every possible angle as it actually was in that moment. And that, right there, is the secret to its mind-blowing realism. And I mean, just look at what this can do. That is not a traditional CGI water simulation. That is a scene rendered entirely with Gaussians. The tech is so powerful, it can capture something as chaotic and complex as splashing water, down to every single droplet and reflection, and then let you fly around it from any angle you want, all in real time. Okay, so we've totally nailed the splat part of 4D splats. But what about the 4D part? Well, let's go ahead and add the fourth dimension: time. I mean, listen to that again. Spatial mapping on the floor. Oh, that's where the time is spent. The lyric is literally connecting a map of space to the passage of time. And that is the absolute core idea of 4D capture, taking that 3D snapshot and putting it into motion. Which, of course, begs the next big question. It's one thing to capture a static object, right? But how in the world do you capture an entire dynamic scene, a moment that's unfolding in time, from every possible angle, all at once? The technical name for it is 4D reconstruction. Some people call it spatio-temporal reconstruction, literally space-time reconstruction. You're not just scanning an object anymore, you're scanning an entire event. And to pull that off, you need a lot of eyes. I mean, companies like Infinite Realities are building these insane capture stages using 196 cameras, all recording high-speed video at the exact same time, just to grab every tiny little nuance of a performance from every conceivable angle. Now here's the absolute game changer. We're not just stringing together a bunch of separate 3D splats like a flipbook. No, the really cutting-edge stuff actually animates the Gaussians themselves. Each little fuzzy blob has a direction and a lifespan. This means you get this incredibly smooth, continuous flow of motion, not a series of choppy frames. It lets you generate crazy high frame rates. We're talking 10,000 plus frames per second, and somehow it's super efficient, making the final file 100 times smaller than the original video. All right, so we've captured a photorealistic moment in both space and time. We have our 4D splat, so what's the next logical step? Well, how about we get it off the screen and into our actual world?
Now, this line, holographic erratic is a habit, this has got to be the most futuristic sounding lyric in the whole song. And it's pointing us toward the ultimate end goal for all of this amazing technology, true three-dimensional holograms.
And look, this isn't just some sci-fi fantasy. As this quote from actual scientific literature confirms, building a real 3D holographic display, one that actually reconstructs a field of light in physical space, is basically considered the holy grail of display technology.
Now, the process for creating one of these is, well, it's incredibly complex, but it follows a pretty logical path. You start with that same point cloud data we talked about, you use that to build a 3D object, then you run it through some heavy-duty algorithms to figure out the exact pattern of light waves that would create that object, and finally, you project that pattern to literally rebuild the object in real space. And just so you know, this isn't all theory, this is what it actually looks like in the lab. You've got a laser, beam splitters, a bunch of lenses, all working together to take that digital data and physically recreate the light itself, creating a true 3D image that's just floating there in space. Okay, deep breath. We followed the lyrical clues from point clouds to 4D splats all the way to holograms. So let's tie it all together and figure out what this new reality actually looks like. Honestly, the applications here are just staggering. We can digitally preserve priceless historical landmarks that might be lost forever. We can create entertainment for VR that feels completely real. It's unlocking visual effects that were just impossible before, like completely changing the lighting in a real scene after it's already been filmed. And it just keeps going. Medicine, e-commerce, real estate, you name it. And this is where it all comes full circle. The final piece of the puzzle is that all these technologies are actually merging. Brand new research is pioneering a technique called, and you can't make this up, Gaussian wave splatting. And its whole purpose is to create a super efficient way to turn these photorealistic Gaussian scenes directly into holograms. The song wasn't just being poetic, it was being prophetic. So, we're moving past photos and videos. We're entering a world of replayable, explorable moments. We are right on the verge of being able to capture reality itself. Which leaves us with a pretty huge question to think about. When we can capture and relive any moment we want from any angle, what does that do to the very idea of a memory?